Hello, I'm Richard Patterson and welcome to another episode presented by IPC Irwin. And in this demonstration, we're going to look at these pieces of equipment: an IPC Irwin student power supply, which has got the key here to make sure students use it at the correct potential difference or voltage. IPC Irwin Voltmeter, this is a DC voltmeter measuring between 0 and 20 volts. We've got an incandescent 24 watt lamp there, maximum PD 12 volts, and a laboratory variable resistor. So I'm just going to show you the ways we can use this component together with these to help us do some electrical investigations. And students sometimes get mixed up with the way we connect this piece of apparatus, and they waste time and the experiment doesn't appear to work. So if we can just look at the connections of the variable resistor, you'll notice that there are 3 connections to it, as opposed to these pieces of equipment, which have only got 2. And that is the problem that students sometimes encounter. So let's just focus on those connections with this shot coming up now. So it's worth spending a minute or two studying this component and looking at its construction, and that'll help save a lot of time later on. If as a teacher, for example, you're trying to fault find circuits. So the variable resistor is this length of resistance wire wound on this ceramic former. So it's just a length of wire coiled around here, and it has 2 end connections here and here. So if we put this into a circuit, it's going to provide a resistance of so many ohms. There's a rating plate here. I think this is around 50 ohms on the side of the variable resistor here for you to read off. You may find that in your school lab there are different size resistors. It's make sure you don't get them mixed up. So if you've got 2.5 ohm ones, they're going to perform differently to 50 ohm variable resistors when you use them in circuits, and be aware of the sizes of these. But how do we change the resistance? And that's the important point here. Well, we have a metal bar which has a sliding contact on the metal wire here. It actually makes contact with the wire, and this control moves along this bar here, and here's our connection to it. So when we connect it into the circuit, we've got to make sure we choose which of these terminals we use depending on the purpose. So the variable resistor can be used in 2 ways. It can be used in what we call a rheostat mode, using 2 connections only, and that basically changes the current in the circuit. And the more complicated method is to use all 3, and that's known as a potential divider circuit, which is used in quite a few senior high school experiments when we're looking at the current voltage characteristics of various components. Now, students look at this and think it's come out of Victorian times, and indeed they were used then. But the connection with their everyday life is that we can get this component and we can twist it round into almost a circle and miniaturize it, and that's when they're probably familiar with these variable resistors, which we use for dimmer switches, on some controls for kitchen appliances. And if we look underneath, the circular case there basically hides a variable resistor which has been formed, in this case using a carbon strip. Now, these variable resistors are not to be used for most science experiments because the current they can handle is very low, and they'll heat up and burn out. So now I'm going to show you the simplest way of connecting the variable resistor, and this is in what we call rheostat mode. We just use 2 connections, and all it will do is vary the current in the circuit. So if we want to actually reduce the potential difference across this lamp, this isn't going to work. We all have a very small potential difference across here, which in some cases is important. So we'll use our IPC student power supply here. This is the one that's got the key on it, and we'll connect the rheostat mode by simply coming into one of the connections of the coil. It doesn't matter which one, and then we go to the sliding contact like so. If students connect it across here, no matter how much they adjust it, it won't make any difference because the sliding control isn't connected. So we've got it in basic rheostat mode. We'll come into the lamp and continue our series circuit back to the power supply like so. If I switch on at the back, the lamp is illuminated, and by adjusting this control, we can vary the current in the circuit, but even at the lowest end, there is still a potential difference across the lamp. We haven't reduced the potential difference to zero because this is always in series. So what I'm going to do next, in the next sequence, is show you the potential divider, which is used for senior high school for IV characteristics and is much more useful than this mode. The potential divider, we need all three connections. So I'm going to begin connecting the coil of wire directly to the power supply, like so. So basically, as you see in this graphic, connected the resistance across the power supply. We then need to come out from the slider and connect one side of our lamp to the control, and the other side of the lamp needs to go to either end of the variable resistor there. So switch on, and by moving the slider from one end to the other, we can now extinguish the lamp. There's now no potential difference, as you could see in the second graphic, across the lamp, and by using the IPC Irwin Voltmeter, we can show that as well. So I'll connect the voltmeter in parallel with our lamp, and we're able to record the potential difference across it. And you should see now that it varies from maximum to zero. So I'll switch on there, switch on the voltmeter, and the voltmeter is now displaying, I hope you can see, 11.1 volts. So as we move the potential divider slider down, we're getting down, and when we reach this end, the lamp is fully extinguished and the potential difference is reading zero. Well, thank you for watching our video. Please have a look at the QR code and the links it leads to. We've got the usual IPC Irwin site for full operating instructions and a few teaching notes. We've included the IOP Spark practical site where you can look at the full range of electrical demonstrations and experiments you could do using this equipment. And we've also included the CLEAP site for safety when using low voltage power supplies, meters, lamps and resistors.